Good day, everybody. This is Mike Leibovitz. We have an exciting episode of On the Fly Wi-Fi. Certainly happy to have everyone join us today. Today we have an excellent guest, Jussi. Why don't you spend a minute introducing yourself? I always seem to fail when I introduce people on their own behalf, but a great guest. Thank you for your time today, Jussi. Why don't you spend a minute to introduce yourself and Ekahau and tell us.
Thank you, Mike. Aren't you going to say my last name?
I tried. I think I said it right before, Kivanimi.
You got it, man. Better every time. Yeah. Hey, guys. I'm Jussi Kiviniemi. Work for Ekahau. We do the site survey, planning, all that kind of stuff. Ekahau also does location tracking systems for healthcare and education. I have little to do with that business, but I have everything to do with the Wi-Fi tools business. So, again, the site survey planning tools. My role is kind of, you could say I'm the janitor at the company because I do all the stuff that nobody else wants to do, and then try to stay out of people's way mostly. So yeah, that's me.
The company.
Thanks so much, Mike, for having me on. I really do appreciate this.
Yeah, no, and I know that we're big fans here at Extreme Networks. We absolutely use your tool set, our pre-sales engineers, and a lot of our partners as well, our channel community. Pretty big fan of Ekahau. But you guys have been around for a little while. You guys aren't running a 1.0 technology here. Why don't you take us back to the beginning? Clearly there was a need at a certain point in time. Wi-Fi was probably pretty immature when you guys started. Somebody had the idea that, hey, we should plan before we start popping APs into networks. How did that come to be?
Yeah, I mean, Wi-Fi was immature, and so was I, but I still am. Wi-Fi certainly is not. It's been a long road, I agree. So we actually accidentally run into this business. There was no Wi-Fi site survey tools back in the day. In like 2001, 2002, when we were doing the first versions of our location tracking engine, that's kind of when it all started. So somehow you needed to, what we call, calibrate the location engine. So you needed to go around the floor plan and kind of click I'm here, click I'm here, so that the location system understood the signal environment. And then the location calibration tool also had some lightweight heat mapping capabilities. The guys built it just because they needed to understand the RF environment to build good location systems. Now, we had a free, let's say, trial version of that location calibrator, and people started using that free trial version to do site surveys on their Wi-Fi networks. And we were like, what are these site surveys? We don't know what they are. We need to find out because maybe there's a business opportunity here. And that's kind of how it all started. We started the site survey tool specification and development in 2002, I believe. Yeah, later part of 2002. The first product was officially released early 2003. It was just a site survey tool. I think it was 802.11b only. It used the Proxim, Lucent, Orinoco cards. Not much there. Version maybe 1.5 then had ABG, and we kind of built it forward from there. Released a planner in 2004. So yeah, it was a time when there was no site survey tools available, so we kind of had to stumble on every stone and kind of figure it out ourselves. But and we were about to kill the business a couple of times because nobody was really buying the tool. Like 2 people were buying the tool. But then at some point when we were about to kill the business, big orders started to come in and people started to care more about their Wi-Fi networks. Maybe late 2003, something like that. And then we actually OEM'd the tool to a company called Airspace that was acquired by Cisco, and that was a pretty big thing for us and stuff like that. So that's how it all started, and it went forward from there.
Yeah, it's interesting. I didn't know, actually, I hadn't heard the backgrounds going to the, I guess, to the RTLS side of your business and how that kind of came to be. Although quite often when you build good technology, people find use cases that you weren't thinking about from an engineering perspective or from a market requirement perspective. And lo and behold, people find cool things to do with your technology, and I guess they helped you guys formulate a second line of business. You talked a little bit about OEMing, and it's early on. It's kind of interesting because a number of Wi-Fi vendors have integrated planning tools yet, Ekahau remains kind of a de facto choice in terms of people using it, certainly Wi-Fi professionals out there in terms of designing Wi-Fi systems. Why is that? What is it that Ekahau has that's special compared to vendors that have their own integrated planning capability?
Yeah, which are often even free, right?
Mm-hmm.
We don't. We just we just do a better job at marketing. Just, no, I'm kidding. So I would divide these as two different tool groups and two different user groups as well. So the integrated planning tools, the ones that many vendors have, they are usually for sales and budgetary purposes. So you can get, first of all, an SE can quickly show his customer pretty heat maps and get a rough order of magnitude estimate on how many APs am I roughly going to need at this site. So he knows that it's closer to 200 APs than 2,000 in this hospital campus, for example. And that's how these free Wi-Fi planning tools are often used. And then when it comes to actually figuring out the exact number of APs, the exact placement of APs, antenna alignments, things like that. Where do I need a more dense network versus where does a more sparse network suffice? Capacity planning, things like that. That's when you kind of take our tool into use when it comes to planning. And of course, then there's the whole integrated site survey part to our tool, which the free planners don't have. So you can take the same data, the prediction data, and then on top of that kind of start doing site surveys and then easily compare those and stuff like that. So to me, that's kind of the differentiation, and I think both tools are good and both tools are necessary in this market.
Well, and it's an interesting point because I guess a lot of people think about survey tools or predictive planning tools as maybe all that you need for a successful Wi-Fi deployment. I think you're kind of touching on it a little bit. In terms of a predictive plan, how accurate do you typically, how accurate would you say to an end customer, a predictive survey alone is 80%, 90%. Without the actual survey, walking through pre and post. What are your thoughts there, and what do you normally prescribe to customers?
This is an interesting question, of course, right? And my friend Jim Florwick tends to say, if you don't ask the right questions, you don't get the right answer. So and what I like to say is garbage in, garbage out kind of a thing. So it's not accurate at all if you don't spend some time kind of defining the environment into the tool. So drawing the main walls might be a good idea, and kind of defining elevator shafts and things like that. But if you spend some time defining the environment, our customers are seeing somewhere, and now I'm going to get shot, but 90 to 95% accurate is usually what they're seeing for when I ask people on what are your experiences. That's kind of what we're seeing, and some people, believe it or not, are just using the planner to do the whole rollout. So I've seen cases where you deploy, design and deploy 100 logistics centers with only predictive planning. Not that I recommend it to anybody, but if you're really qualified or you're a trained user and you spend a lot of time in the planning, it will be fairly accurate. And the tools have come a long way. They have things like we have like 500 antennas modeled in 3D and 400 APs and antennas, including all of your guys' gear there, of course. And there's things like antenna up tilt, down tilt, the height of the walls. You can even define, let's say, masses of people sitting on top of the APs and stuff like that, which for your stadium designs they could be of some assistance, stuff like that. So yeah, that's kind of the thing. So garbage in, garbage out. But if you take your time, it will be fairly accurate. But still, I would highly recommend go on site and kind of understand the RF environment after, so that you can fix the discrepancies, the differences between the plan and the actual environment.
Right. So I guess one of the things that often comes up in conversation is around, and I think you were just touching on it in terms of understanding the environmental and getting that into the plan tool in terms of loss characteristics of walls and all the other stuff. How technical, or if you're a new user to Ekahau, how hard is it now to actually use the tool compared to maybe a few years ago? I know, drawing walls and understanding these characteristics. I mean, do you need to be a PhD level understanding of building materials and RF to be successful with the tool?
Good question. PhD usually doesn't cut it, so you need some postdoc studies, let's say 5-10 years of postdoc research to really operate it. So that's kind of where we are. We're trying to make it harder and harder every year, so that RF is no fun and games, right?
Right, exactly.
So here's the thing. Wi-Fi already as itself as a technology, and especially with N bringing MIMO and AC, going even further from there, the technology itself already is like ultra complex, and then you throw in the customers and the customer requirements and managing expectations and client devices and all that kind of stuff. It's up to us, you guys and us, to make the tools and the infrastructure at least manageably easy, and that's kind of one of the big challenges. And I feel we've done a fairly good job. I think if you go to Twitter or somewhere else, you will get a more or less biased opinion on how easy to use our tool is. But that's kind of been always one of the real focuses on our tool. Like some tools out there, they take pride in being scientific.
Yep.
Granted, but to me that's like that's a given. It has to be scientific. It has to be accurate. But the beauty is when you get a really hard problem and you make it easy to use for the end customer. And yeah, it's a cliche, but Apple is like really good at this, like turning complex technology into easy to use products. And that's kind of like what everybody's striving for, including us. So we do spend a considerable amount of time, whenever we bring something new, not to break the old, to respect the existing user base, and still, keeping the product easy to use for the first-time user as well. So you could say there's two layers to our product. For the new user, the basic buttons are there in front of you, and you can, get going pretty quickly. An example would be for a newcomer to start site surveying. All you need to do is bring in a map and start clicking on the map. You don't even need to set the scale. You can set that even later and stuff like that. So just bring in the map and start clicking on the map. That's kind of the idea. So all the Wi-Fi adapters are configured automatically, with good defaults and stuff like that. So at least we're trying to think about it, but with a tool set that it's been developed for 12 years and it has a ton of bells and whistles, just like your Wi-Fi infrastructure. It's not really super straightforward to make it super easy, right?
So, I mean, you touch on a little bit about 11AC. I'm sure probably you get asked the question all the time. I think most people out there have considered, capacity versus coverage designs, and I think over the last few years, most people have shifted to capacity designs first and foremost. Of course, you need coverage to make that happen in channel reuse, efficient channel design. I have to imagine that you guys get asked probably more than most around 11AC, and we can talk about Wave 1 technology. I don't know if we necessarily want to talk about Wave 2, but even from a Wave 1 perspective, now we're talking wider channels, different signal-to-noise requirements. How different or dramatically different are the planning characteristics, for the customers that you've been working with, looking for 11AC, and are they really looking for, VHT rates everywhere? Is it even possible to design around VHT rates everywhere?
Yeah, well, let's face it, 802.11n and especially AC there, they bring some additions to the coverage, like transmit beamforming, stuff like that, and especially the coverage is more robust at the cell edge and stuff like that. But that's not the thing. And like when N came out, like, yeah, it's gonna have so good range that I'm not gonna need as many AP, stuff like that. Let's forget about that. They're all about capacity. If you're deploying, N and AC, you're getting the benefits in capacity, and that's kind of the thing that we've also tried to emphasize and then modify this, the feature set accordingly. So we brought our capacity planner already, like, I don't know, 3 years ago, 4 years ago, something like that. So we were almost too early with that because nobody was using it, and we were like, did we do this all for nothing? But now people are really using it. So the idea is that you know, define how many client devices, what type of client devices do you have, you know, legacy versus AC versus laptop versus you know, smartphone, and then you also define, if you want to go deeper, you can define, you know, what kind of applications are run on each device, and you know, how long are they utilized per day. That's kind of the idea in our capacity planner, and then you start drilling down from there. The tool automatically spreads those clients virtually across the site, virtually creates all those packets and prioritizes them, you know, whether voice or data or FTP, you know, TCP, UDP, what have you, and then spits out a red-green report saying that, you know, the network works in most areas, but this AP is overloaded with simultaneous voice calls, you know, way too many simultaneous voice calls. This poor area here is running out of airtime, and there's too many associations on this AP. So it kind of spits out this kind of basic level capacity report, and then, or a heat map, and then you can start drilling down from there, like how many clients are associated on each AP and each radio and things like that. So that's kind of our way of looking at the capacity stuff. And when it comes to automatic placement of APs, we have two ways of doing that. You need to define your coverage requirements. So say whether you want to do VoIP or email or, you know, video. So that kind of dictates the coverage requirements. And then the capacity kind of comes on top of that. So it's optional. So if you want to consider capacity, then just tell me how many clients you will have, and then if needed, the tool will make the network plan more dense based on your capacity requirements. That's kind of the idea. And sorry for the long monologue.
No, that's great.
I saw Keith was in your show, Keith Parsons was in your show a few weeks ago, and together with Keith, actually, we also, you talked about channel reuse, you know, wider channel stuff like that. That's super important, like co-channel interference, you know, super important. So together with Keith, we spent a considerable amount of time to improve our code channel analysis and optimization features. So now we feel we kind of have it laid down where in a single heat map you can see all the CCAs and ACA problems, both for 2.4 and 5 gigahertz, and it's easy for you to tune not just the channel width, but the channel allocation, the transmit powers, things like that. So to answer your question, yeah, it's getting more and more, not just toward capacity, but channel reuse, which is related directly to capacity.
Right, and I guess the next element or the layer that kind of builds above it, and maybe we could talk about it for a minute, because this always seems to be the magic with planning when people start talking about, you know, 3D tools and being able to run across multiple floors. So it kind of seems like sometimes, you know, the conversation rotates around to say, okay, I planned one floor, but what happens to the Wi-Fi on the floor above or the floor before or the floor below it, and how plans work in that perspective, and whether or not, you know, 3D modeling tools are accurate, not accurate. Where do you guys go in terms of multi-floor designs?
Good question, and I'm glad you asked. I would, when the focus goes more to capacity, then people also tend to go back to the basics as well. So I would say there's 3 good ways of planning capacity, from the simplest to the most complex. First one would be, you know, forget about the maps, just do an Excel or similar capacity type of calculation where you throw in, you know, the specs of the APs, the numbers of clients, stuff like that, and then the calculator will calculate the capacity, no map considered. Then the second one would be you have a single floor map, and then the third level of complexity is you have a 3-dimensional model that's multi-floor. So as for multi-floor and the accuracy related to it, I think the tools it is accurate if you again define, you know, it's another garbage in, garbage out. You need to define the material that goes between the floors and things like that, but that's not alone enough. The tool needs to be like completely 3-dimensional in terms of algorithms to to understand the three-dimensional nature. If you just, if you don't have that full three-dimensionality, then you're doing what I would call like 2.1D or 2.5D, where you just add some attenuation between the floors directly, and that's it. But obviously that's not going to work. So you need to kind of this goes into details, but you need to ray trace the signals and trace those, first of all, in the floor where the AP is at, and then move into the second floor and do it all in 3 dimensions. And you need to take into account, the height of the walls and the cubicles and things like that, just bring more realism into that 3D calculation. So floor-to-floor prediction, in short, it has a fairly bad name perhaps for some, like it's not accurate, things like that. But that's because some of the earlier and still some of the tools out in the market, they do this 2.5D, which really, it's not realistic, and it may lead to inaccurate results.
Would you say, I mean, so even measuring like attenuation between floors, like would you suggest that you basically need to take an AP on a floor and take your client device, whether you're using a measurement tool or just any device, and actually try to measure the attenuation that you see through the floor in a manual? I mean, if you were taking that sort of approach and inputting that into Ekahau, I would imagine that your results would be that much more accurate. Or do you see the need to do that still?
Ideally, that would be the process, and a lot of people do go on site to kind of, fine-tune the plan, which is definitely a good idea. So ideally, that's exactly what you would do. You would take measurements in different floors and compare the delta, and then fine-tune the plan accordingly. We do have preset values for like a typical hotel, a typical hospital, a typical office, things like that. But if you go actually on site and make the measurements yourself, both for walls and for the floor materials, then you'll get a better result.
So if you had your choice, let's say hypothetical here, would you sooner recommend, if you could only do one, pre or post survey, which would you recommend as the absolute, you have to do this?
Good question. First of all, I would split this into 3 parts, so 3 main parts. There's the off-site design or the simulation or predictive surveys, whatever you call it, predictive designs. Then there's the pre-deployment, which is AP on a stick, and this is where you typically, can go back. After this, you can go back to the plan and kind of modify the value, stuff like that. AP on a stick meaning that you obviously take the AP or several, put it into place number 1, do a survey, move that AP into place number 2, you do a survey, stuff like that. And then the third one is the post-deployment validation survey, where you kind of, you have the network set up, and then you go around the site once to measure that everything is working as it was supposed to. Gun on my head, if I only had to choose one, I would go with post-deployment validation, because, if the final network is not working, you're dead in the water. Granted, you can't neglect the other phases either, and some people like to do, for example, predictive plus post-deployment. Some people like to do all 3. Some people like to put less value in predictive and do more AP on a stick. All of these are good. I would say at least 2 out of these 3 would be necessary.
It's interesting because I think over the years, and I wonder, if we took just a national poll around the world, what people think. It seems like over the years where many people didn't do a post-validation, it was almost like you were leaving it up to the end users, right?
Yeah.
Wait for the end users to start complaining and tell you that you have coverage gaps. It seems like more people understand the value of at least baselining the network after it's been deployed with some sort of tool and try to marry up the plan and the reality of what you had. So at least on day 1, the first day of the rest of your life, you have a baseline to determine, hey, this is where we've started, and this is what it was, right? I
agree. Things are getting much better, and guys like CWNP organization, you had Tom Carpenter in your show, just a few weeks ago. They had a great conference too, just a few weeks ago. So those guys, for example, do a really good job at educating the industry, and then they turn their CWNEs, which is the highest level of certificates you can get from CWNP. You have like 150 of those guys, including Devin Aiken, Keith Parsons, and all these guys. So those guys also become kind of evangelists for good quality Wi-Fi and these processes that you need to follow and things like that. So definitely things are getting better. I totally agree with you. Much better than what it used to be. Back in 2002, people were using, and some still are. You see this, like people are using pen and paper to kind of draw the coverage areas, and then and that's okay. But the fact that people are just looking at the floor plan and then saying, without RF experience, saying, yeah, we probably just put a few APs here, and here, and then they draw circles around the APs, and there you go. So, but less and less of that, and more of professionalism is what we're seeing as well.
I guess the long-standing saying, "Failure to plan is planning to fail," is still a valid statement in the world of Wi-Fi, at least. Hopefully, high quality, better quality Wi-Fi everywhere we go. So before we wrap up, I'll give you maybe just a minute or two here. What does the future look like? To me, it seems like Wi-Fi planning doesn't go away; it becomes more and more relevant as time. Interestingly, as time proceeds, it's more important, not less important to plan. But in your eyes, what does the future holds for Ekahau, for the realm of Wi-Fi planning?
So how should I put this without giving out too much? There's two things really that we need to care about. Actually three. So first of all, we need to take a good care of our existing customers and customers like that. So guys like you and Will Aguilar and Sean Hoxton and those guys who are experts in Wi-Fi and need expert quality tools that are super accurate but super fast to use. That's kind of the first thing. We need to take a good care of that, and that's why we're on Twitter all the time, and we try to absorb all the feedback we get, stuff like that, talking with the community, guys like you, guys like Keith. You know how it goes. Yep. Second one is the ease of use. So and this is what we talked about. So Wi-Fi is so complex. We need to make our tools even easier. And there's more and more Wi-Fi engineers coming, either from school or from the fixed Ethernet world or whatever. For those guys, we need to make the tools easier to use so that they can, just jump on board and start using the tools. And the third one would be, new product lines solving different problems than what Ekahau as a company solves today. So I think we do a fairly good job at enterprise Wi-Fi planning and validation, but there's a lot of other things as well in the field, obviously, that these professionals need.
Awesome. Well, I certainly appreciate your time. This time I will say thank you to Jussi Kivenniemi. Hopefully I put it properly this time. Ekahau, the VP of Tools, certainly appreciate your time today. Always interesting to hear about the wide world of Wi-Fi planning, or the wild world, if you will. Again, thank you very much for your time. Certainly appreciate it today.
Thanks so much, Mike. I really do appreciate the opportunity, and yeah, it's good to be here today. By the way, Mike, I hope you returned the favor, so I hope to see you in one of our webinars later on then.
Yes, I missed my opportunity to be, and I saw you guys posted some of the little clips from the CWNP conference, so I certainly would love an opportunity to join you guys anytime, any place. I live my world virtually through a camera and the internet.
Awesome. And if it's anytime, any place, you're welcome to the Finland office whenever you like.
Very nice. Maybe we'll have to do an episode on the fly from Finland. That would be pretty cool.
Exactly.
Well, with that, I'm going to sign off. Again, I appreciate everybody's time for watching today, and I appreciate Jussi's and Ekahau's time to join us today. And with that, I'm going to sign off. Thank you very much.
Thanks a lot, Mike. Thanks a lot, everybody.